The Life Cycle of Stars, an animation project by Bray Russell and Autumn Mull. At the beginning of the Big Bang, tons of matter and energy were expelled out into the void. However, all the matter was just tons of little particles because it was too hot for it to clump together. Once the temperature cooled down, though, hydrogen and helium were able to form.
Gravity, something spectacular became written in the stars. Particles had to become extremely hot and dense at temperatures coming at 10 million degrees Celsius. The extreme temperatures were due to the incredible density of the stars, since when things become more hot and dense, strong nuclear force allows protons to fuse and release impeccable amounts of energy. The process took about, 300,000 years to start forming the stars, but we all know when observed in the night sky, the time was worth the dazzling beauty scattered in space.
Fusion occurs in the center of a star. Hydrogen and hydrogen start out, which both have one electron and proton, to make helium, which has 2 electrons and protons. This occurs in the center of a star and ends up creating 25 new elements.
Remember this, folks. Gravity plus helium plus hydrogen, and because they all, all those guys, they, basically hydrogen and helium, they equal stars. And stars are amazing! Bray ships it. Let's talk about the life cycle of low-mass stars! Yeah! Okay, a low-mass star starts out in the stellar nebula. Then what happens is that it goes from a little tiny bitty little thing to a star about the size of our sun. And this process lasts way longer than a high-mass star. In its inception, a low-mass star becomes a red giant. But when no longer hydrogen is in the core, nuclear fusion, which wants to tear the star apart, goes head-to-head with gravity, which wants to push the star together and crush it into nothing. So the whole huge red zit welt thing, before it becomes a red giant, and captivates itself. First, hydrogen will burn for 7 billion years, helium will burn for 700,000 years, carbon for 600 years, neon for a year, oxygen for 6 months, silicon for a day, and iron for a quarter of a second. The death of a low-mass star is called a nova. Very, very boring. But after a nova, it will go to the planetary nebula stage. My drawings catch up with my narrations. Hey, look, it's nova. So here's a boring planetary nebula. Just kidding, it's really pretty. So after that, it will go to a white dwarf stage, which everyone thinks it's a giant diamond in the sky because the only element it is carbon. Sometimes it'll go to a black dwarf stage, which it's cold carbon, so it's no longer luminous, and then it will finally return to the planetary nebula.
Okay, let's talk about the life cycle of high-mass stars. Like all stars, they start out in the planetary nebula. That is definitely dust stuff. And hydrogen and helium. I'm so good at drawing, aren't I? Give it seriously. Our sun and the minimum size for a high-mass star is about 1/3 the size of that. So 3 suns bigger, and you get a high-mass star. The second part of it is a main sequence, which is about 90% of the star's life, which is about 90 million years. After that, it becomes a red giant, just like a low-mass star. It becomes all red and big and bloated and ugly, like small children. Wait, that was just me, never mind. So it's about 10% of the star's life, or 10 million years. After that, it goes supernova, which is like a nova, but it's super, like me. So it's only a couple seconds long, but expels about 90% of the star stuff into the universe and creates all the other elements. After that, high mass star has two options. Some high mass stars will turn into neutron stars, which is a big ball of light stuff, and others will turn into a black hole, where the remaining matter of the star has such high gravity that not even light can escape. That lasts about 10 to the 70th light years, and a neutron star lasts about 10 to the 35th to 45th light years. Lastly, the black holes and neutron stars dissolve and return to the planetary nebula. The end.
New chemical elements! Yay! Alright, let's get this started. So, when stars are old, like really old, and then they die, and because they're so hot and new, which equals new elements, like iron, because iron, well, that's the death of all stars, plus fusion, inside the supernova, which the supernova expels all these new kind of elements. So, all the new kind of elements are like 92 of them, which includes the compounds such as water, H2O, and we have to know chemistry in order to understand this. All coming from a supernova. So why do we have to know chemistry? Well, hydrogen and helium equals stars, and which equals new elements, like the following. And that may be too complex for you, but you have to understand it because life is complexity. And life is us. And don't forget those isotopes, because complexity is us, because we are super complex like stars, and stars are complex, and stars are us, because we are stars, each and every one of us.